Hello, this is a tutorial about certain statistical analysis tests, including t-test and Anova test, as well as chi-square and correlation. So this is a raw data that I got from internet, and it contains information about mobile cellular subscription rates per 100 people, and certain other telecommunication records in different countries. So what I did in the beginning was to get or filter for countries and get their data from 2001 to 2017, and then calculate certain parameters. So the first thing that we need to do in order to calculate t-test is to analyze box plot. So we conduct box plot analysis. You can have this like this. So these are the 4 countries, the distribution of the parameter in those 4 countries, and we can see that Zambia is quite different from the United States in those 17 or 18 years. The same goes for Zimbabwe and the United States. These 2 countries here are quite different from the world, and they are also quite similar to one another. So this gives us a general idea. So I'll let you know how to generate this box plot. And after that, we've got to analyze the mean for each one of them and the variance. We'll do that. Then we'll generate a time series out of the 4 countries, the data for those 4 countries. Actually, this one is the whole world data. It's not just the countries. Once the means and variance are calculated, we'd analyze the differences among the countries and then between each 2 countries to see which one to pick up to do the analysis and see the results for pairwise analysis. So this example here is a comparison between Zimbabwe and Zambia. So after that, we'll conduct the t-test. This is just to see whether there is a significant difference or not. So let's go ahead and do that real quick. We'll get the raw data first. So this is the raw data, and we'll put it somewhere in your sheet. The data point, as you can see, each data point has loads of decimal points. It's best to minimize it to see the data clearly. You can have another column here to write down the name of the parameters. Let's say we need mean, we need variance, and etc. So you could get the average for this one here, for this country, and the standard deviation, then the variance, or you could just write down var s for that country. For sample, this is just a sample set. Then you could go and apply the formula for the other countries. Well, this gives us a general idea about it. We can get more ideas if we have a box plot generated. So we can get a box plot like this from this data or from the series, each series on its own. So we can go for box and whisker here, and that's how the box plot is generated. So yeah, this box plot is the same as what we generated earlier. We can add the labels, like adding chart labels here. You could go for each one of these and manually add the labels. Yeah. So let's add the legend. So this will add a legend to it, and we can have a chart title here. Let's say box plot analysis of the 4 countries, or name the countries that you want. So Once we generate this, we can also go for generating another chart analyzing the mean and the variance as well as the standard deviation. So we could get like the standard deviation for the samples. So for this sample, we first label it like this is the STDEV, which is standard deviation. Then we go like STDEV.S. Then we choose the data series that we want to conduct the standard deviation for, minimize the number of decimal points we want to return, and this is the standard deviation. We need to count the number of samples we have here. This should be the same for the others because it's obvious, like they are all the same data sets collected, like the same number of data points collected for each in the data series. Then we need to calculate the standard error of mean. So the standard error of mean is equal to the standard deviation of each data series divided by the square root of the number of samples you have per series. So this way we can get descriptive statistics or descriptive measures about our data, and now we can generate our plot for the mean in order to have more information. Yeah. So this gives us quite a lot of information about the distribution as well as the box plot analysis that we did. We can tweak the chart, like format the data series. We can minimize the gap between each pair of countries, and then we can add up the standard errors as whiskers, the error bars. So what we do is that we select the standard error of mean and add it to each one of them. Now the errors are added up to them. This gives a more general idea about the countries. We can also add the legend here as well, like this is the mean, but that is not necessary. Or we can have the data labels on them or the axis titles. So feel free to add the information that you require to have. Now we can see that from the mean that these two are not that much different from one another. So this is similar to what we got in the box plot analysis, but the box plot gave us more ideas about the distribution. This one gives us ideas about the mean and the data errors around the mean. Now let's conduct the required pieces of information tests to get more information, like whether one is more significant or the other is more significant to compare. Like let's say the variance here is not similar. So if we conduct a t-test, we have to bear that in mind, that the variance is not similar. So there is a difference in the variance. So the t-test that we conduct should be for those kind of t-tests that require differences in variance, not similar variance. The means are also quite different. So we'll pick, let's say, Zambia and United States. We copy those, try and paste it here. Now we have these two countries. As we do that, we can go for data analysis, then pick t-test. Now we conduct t-test to samples assuming unequal variances, because we know that their variances are not similar. Yeah, one of them is 889, the other is 607. Now we choose the data range. This is the whole data range that we have, the first data series and then the second variable. Then we tell them that the label is in the first row, or we have labels here. As for hypothesized mean difference, we hypothesize that there is a 0 mean difference between the two. And this is to conduct the experiment based on the hypothesized mean difference. So the alpha, the subset of alpha that we choose is 0.05, and this is important to notice because we mean by this that we are 95% sure of our decision later on. So we can tell Excel to put an output range here and press OK. And then this is the output from the test that we got. The numbers of one tail and two tail that are given to you are in scientific format. You can go and change this to number, and it will tell you that there is a significant difference both in the one tail or two tail. So this one here is the two-tailed, and it means that the difference is statistically significant, and the result that we got is not by chance. The p-value is not by chance. So if this is smaller than 0.05, you would say that there is a significant difference. Right, so we have to note this thing down on the table, like this country is significantly different from that country. To be able to do that, there are loads of options that you can do. So you could just draw a line like this and go to shape outline, increase the weight, change the color to black, and you can also have a kind of a arrow showing it, yeah, like this. Yeah. So you would say that I had these two countries being compared, and the p-value is different. So you would say that there is a significant difference. P is smaller than 0.05. Or you could write down your p-value. You could say p-value is equal to that. This is how you represent your t-test between two data points, or data sets actually. So you could also go for showing the average, like we have this mean and this mean. And then write down the means here, the name of the countries as well. So you have United States and Zambia. You can generate the chart for those two, then do the same thing. Like you could do the same tweaking we did for the previous chart and bring these two shapes down here. You can tweak this. Oops. Simply add a line. Like this. You could also put the p-value here, and you can draw yet other lines, like to further emphasize that this is where you see the difference between these two. You can have this black like this, and then draw yet another line here. That's it. So this is how you show your result of t-test between the average that have been calculated for two countries or two different data series. Right. What if you have more than two comparisons? Like you want to perform multiple comparisons. So what you can do is to basically generate a data series analysis or time series analysis, see whether there is a real difference visually. So when you do that, you get options for time series charts, and this shows you that they all have changed over time, but you may not know whether which one has significantly changed in comparison to one another or the other. To perform this or to analyze this, what you've got to do is to perform a deeper analysis, which is called analysis of variance. So here we have the same data or raw data, and we want to conduct analysis of variance. The easiest way in Excel to do so is to go to data analysis and choose Anova one factor or single factor Anova. You choose your data set, you tell it that the labels are in the first row, you have the alpha, subset of alpha being set to 0.05, and the output range is being put here. So press OK, and you get the Anova output. Here it gives you the p-value of the Anova test, which is 0.0001, and it states that there is a high significant difference among the data series that we fed into the Anova. What we can do after that is to perform pairwise t-tests, assuming equal variances. This is different from the t-test that we already compared. So you do pairwise, like Zambia compared to Zimbabwe, Zambia compared to the world, Zambia compared to the United States, then Zimbabwe compared to the world, Zimbabwe to the United States, finally the world compared to the United States. You don't do it backwards because we do two-tailed tests. So let's compare Zambia to Zimbabwe. So this one here, we go to data analysis. This time t-test for two samples assuming equal variances. So we have the first data series here and the second data series here, and we hypothesize that there is a zero difference between the two. The output range is here. Now it gives us this output, and as for the p-value, for two-tailed p-value, you would see that there is 0.77 as the output. This is not significant in itself, but you have to perform Chauffe correction or Chauffe PostHoc. This is called PostHoc test. So this is equal. The number of data series that you fed to the Anova is 4 here. So this is equal to this number divided by 4. Now this is the p-value of the PostHoc test. Yeah, this is the easiest way of conducting PostHoc test, and you have to report this one after conducting the Anova. This is your PostHoc. Now let's compare Zambia and the world. So this one was not significant at all. Now let's compare Zambia to the world. We go back to data analysis. This time Zambia is the same. Now we change this one to the world, and we change the output to this place here. Now we have Zambia compared to the world, and the p-value is here. It is statistically significant. However, we have to divide this by 4, and we see that when we divide it by 4, it becomes even more statistically significant. So there's a great statistically significant difference between the two variables or the two data series that we have. And you continue like this. This is how you do the deep analysis between each pair of the sample sets that you have, or each pair of the data series that you have. So that's it about PostHoc, and